and we welcome you to today's webinar on foreign object detection in meat processing. Our product inspection system makes a wide range of equipment and solutions to support the food and pharmaceutical industries, including checkwares, metal detection systems, and X-ray systems, and many of these are designed to meet the very unique needs of the meat processing industry. I'd like to introduce today's speakers. They are Alex Kinney and Mike Manelli from our product inspection business. Alex has a background in applications engineering, R&D, and was actually part of the development team for a new Sentinel metal detection and technology platform. Alex is based out of our Minneapolis office, and he works with our customers who request product tests on their samples and supports the development of a lot of the content, including today's program and other materials to support you and your application needs. Mike is based out of the UK, and he's a market manager for our business. He works very closely with our sales organization and our customers, and also has a very strong technical background as well. Like Alex, he develops content to support our customers in the food industry. So with that brief introduction, I'm going to turn it over to Mike and Alex for today's program.
Okay, thank you for the introduction, Ellen, and thank you all for joining. I'm Mike Manelli, and I will be the first presenter today. This presentation will discuss inspection technologies for foreign object detection in the meat processing industry. To introduce Thermo Fisher Scientific, we have 75,000 global employees, including 10,000 customer-facing employees. We have 5,000 in-house scientists and engineers developing and supporting our product lines. Each year, we invest $1 billion of our $25 billion revenues into R&D for new products, and we are committed to supporting our customers now and into the future. Through our portfolio of brands, Thermo Scientific, Applied Biosystems, Invitrogen, Fisher Scientific, and Unity Lab Services, we offer an unmatched combination of innovative technologies, purchasing convenience, and comprehensive services. We can help our customers achieve their goals through the breadth of our latest technology products, a focus on superior service, and a commitment to quality and reliability. We all take pride in our company mission to make the world cleaner, healthier, and safer. And our product inspection products contribute to this mission, helping improve levels of food and pharmaceutical safety. Our customer value proposition focuses on accelerating innovation and enhancing productivity for our customers. In particular, our product inspection product lines help customers comply with regulations and standards, provide reliable, high sensitivity performance to help you optimize your production processes, and the quality of our products help customers ensure their own products are produced at the highest levels of quality. To introduce our discussion today, we will be focusing on the food processing industry. There's a growing global demand for food processing equipment, which is driven by the growing global population, a higher demand for processed and convenience food from consumers, high labor rates, which makes increased automation attractive, increased food safety pressures, and price per unit pressures, which drive need for better efficiencies and improved yield. Thermo Fisher Scientific is a supplier of product inspection equipment to the global meat processing industry. We manufacture, design, and supply check weighing equipment, metal detection systems, and X-ray inspection systems. The application focus for today's presentation will be on the detection of foreign object contaminants in a variety of meat products, including spiced and salted processed products, deli-style layered slices, sausages, moist or bloody whole cuts of meat, and ready-to-eat meals containing meat. We will discuss two technology types. The main focus will be on multi-scan metal detection for the detection of ferrous, non-ferrous, and stainless metal contaminants in food. But we'll also briefly touch upon X-ray inspection systems, which can also detect metal contaminants, but can be used to detect non-metallic contaminants such as bone, stone, plastic, and glass. In order to better introduce the foreign object detection in meat processing application, it's first necessary to touch upon the theory of metal detection technology, and I will now hand over to Alex, who will discuss the metal detection technology and its use in these applications.
Thank you, Mike, for the introduction. As you said, we'll quickly go through some of the basic theory before we dive into the meat processing application. So, a metal detector consists of a transmit coil positioned between two receive coils to form a balanced system. The coils are enclosed in a stainless steel housing which blocks unwanted outside interference. Food product traverses the aperture, depicted as the yellow arrow in the right-hand image. If a metal contaminant is present, an unbalanced voltage signal is created, which will flag a contamination and ultimately trigger a rejection. Signal from food versus metal contamination can be differentiated by a phasing approach, which we'll touch on in the next slide. Metal detector signal is comprised of two components, magnetic and conductive. And it is the ratio of the magnetic and conductive components, which we refer to as the phase angle. Anything that traverses the aperture, whether food product or a metal contaminant, will have a phase angle. So, the metal detector must ignore the phase of the food to reject only the metal. But this becomes a challenge when the product phase aligns with the metal phase, because the metal and food product look similar to the metal detector. We call this challenge product effect, and it is particularly challenging in the meat processing industry. The challenge of product effect can be mitigated by using multi-scan technology, which is the use of 5 frequencies at once. Another way to think about it is it's like using 5 metal detectors in one, each tuned to a different operating frequency to foster unique performance. Using multi-scan, even if a metal contaminant signal is masked by product effect at one frequency, there is a high probability it will be detected on another frequency. The probability of detection is greatly increased, ensuring the food is safe from metal contamination and reducing the risk of inefficient false rejections. Now that we understand some metal detection basics, let's explore meat processing and see how metal detection can be applied. The meat processing market requires the safe processing and packaging of meat products. And by safe, we mean safe from biological contamination like Salmonella or E. coli, and safe from foreign object contamination, which can come from the inbound food supply or in-house processing faults. Avoiding foreign object contamination is important to protect downstream equipment from damage, to protect consumers' health, and to protect the food processor's brand. It's also necessary to comply with food safety standards. A second key market requirement is for reliable process automation, which can be achieved using equipment designed with a focus on meat processing. Equipment must meet performance requirements, like detecting small metal sizes. It must cope with the environmental demands of a meat processing plant, and it will require minimal touch time for setup, use, and maintenance. Selecting the proper inspection solution can help improve process efficiency by reducing scrap and rework, and it optimizes labor use in the plant. It should be acknowledged that metal foreign object detection in meat processing has a special set of challenges that must be overcome. First is the operating environment. Meat processing plants often operate at cold ambient temperatures, sometimes near freezing. Washdown processes, on the other hand, use high temperature, high pressure spray down and may include chemical-based cleaners. These washdowns introduce large temperature swings, which we call thermal shock. The metal detector must not only survive thermal shock, but not compromise performance. Another challenge is the high product effect. Fresh meat is often moist, bloody, and conductive. and any salt or other added spices create even more conductivity and therefore more product effect. Also, production requirements may change. A line may work with different products at different times in the same day, or a single product may itself exhibit variability in level of thaw or size and shape of the pieces of meat as they go through the metal detector. To address these challenges, care must be taken to select the correct metal detection system. The following features should be considered essential for a metal detector to be used in a meat processing plant. The metal detector should include a heavy-duty design. Heavy-duty meaning it should provide a high level of ingress protection with IP69K rating. It should be resilient when cleaned with harsh chemicals and not corrode over time, such as a design with medical grade 316 stainless steel. It should also survive many cycles of thermal shock, which can be achieved using carefully selected soft fill epoxy materials. A resilient metal detector means less downtime and a lower long-term cost of ownership. The metal detector must also provide premium performance. It should be easy to set up and optimize without spending a lot of time or needing intervention from a user. It must compensate difficult product effect so that the smallest metals possible can be found. A high-performing metal detector that can detect small metals means better food safety. It also means less falsely rejected product, so less waste. Additionally, a modern software feature set can overcome some of the finer challenges. A reliable auto-learn feature where one can set it and forget it improves uptime and minimizes labor. Also, a phase tracking feature will enable the metal detector to adjust to changing product conditions on the fly. In meat processing, a common need for phase tracking is during the thaw of a frozen slab of meat. To demonstrate this effect, we performed an experiment in which the product phase and signal level seen by the metal detector was recorded over time as a 2-pound block of ground beef thawed at room temperature. As we can see in the graph below, at 0 minutes, the product phase was around 90 degrees, and just 15 minutes into thaw, the phase changed by about 10 degrees. If this phase change was not automatically tracked and compensated by software, the metal detector would eventually start false rejecting, necessitating intervention by a user. Basically, more automation means less time that a skilled operator is needed to tend to the machine or intervene when things go awry. In this slide, we show some typical application performance for a multi-scan metal detection system inspecting a variety of processed meat products. For this test, a metal detector with size 350 by 150 millimeters aperture was used. One interesting observation here is that the first two applications tested, the garlic herb pork and the sliced roast beef, performed better when a low frequency schedule was used. As a reminder, a multi-scan metal detection system uses 5 flexible discrete frequencies at once. So in the chart, under ideal frequency range, when we see 100 to 300 kilohertz, know that that means 5 frequencies in that range are being utilized to best detect those small metals. A multi-scan metal detector can offer improved performance over single frequency metal detectors anywhere from 10 to 30%. And the flexible, adjustable frequency schedule means it may cover a wide range of applications. While many application capabilities may be estimated based on prior experience, it's important to understand that every new application is still somewhat unique. Testing real product with real packaging in a simulated production environment is still the best way to understand performance. At Thermo Fisher, we provide this testing service free of charge. By sending in samples of product, we'll be able to determine the smallest ferrous, non-ferrous, and stainless steel metal sizes that can be detected reliably day after day. This provides an accurate prediction of real-world detection capabilities that you can depend on. All testing occurs at our Minneapolis-based laboratory. So please, let us show you how we can support your pursuit for improved food safety and brand protection. My email address will be made available, so I welcome you. Please reach out with inquiries or anything else if you'd like. And with that, I'll thank you and I'll hand it back over to Mike.
Okay, thank you, Alex. So to summarize Alex's discussion, what should users be looking for when selecting a metal detection system for meat processing? The following product features, such as superior detection capability, which can help minimize the risk of contamination and time-wasting false rejections, software with auto-learn and auto-phase tracking features to enable fast, efficient setup and effective ongoing detection performance, will maximize the instrument uptime and free skilled operators for other tasks. Having a robust system design with 316 stainless steel construction rated to IP69K will mean the metal detector will resist damage from thermal shocks and high pressure liquid sprays and corrosion from aggressive cleaning chemicals, giving a low maintenance, long lifetime product that you can rely upon. Having a sanitary design minimizes the risk of food buildup and subsequent biological contamination. And the product testing service will allow a user to see exactly how multi-scan inspection technology can improve food safety and help you protect your brand reputation. Selecting the correct metal detection system can increase the probability of contaminant detection and enhance consumer safety. In addition to metal detection systems, another useful inspection tool is an X-ray inspection system. X-ray can be used as a complementary technique in addition to metal detection in order to meet specific customer requests, where bone detection is required, or to support increasing food quality expectations from the market. X-ray can be used instead of metal detection in certain applications, such as when the product is packed in some type of metal packaging, or when the product exhibits extremely variable product effects. One past limitation with X-ray was the harsh washdown conditions described earlier. But modern X-ray systems are now available with IP69K ingress protection and heavy-duty use features similar to those found on metal detection products. It may be beneficial to consider use of X-ray in addition to metal detection as part of a complete foreign object detection regime. And so that concludes the formal part of our presentation today. Alex and I thank you for listening. To remind you that you can learn more at thermofisher.com/meatinspection. You are welcome to discuss any application needs that you may have directly with Alex, and his email address is shown on the screen here. Or you can contact our sales team. And again, we have the email address shown on the screen. A final thanks, and I wish you a pleasant rest of your day.